dots. So hello everyone and welcome to our webinar today. And today, hopefully as you've seen and read while registering, we're talking about how to build the most reliable and accurate Gen AI platforms and applications possible, make them work really well, make sure they work as expected so you can really derive value from them. And we're focusing on the components entity RAG and LLMs like GPT as a key component of making these LLMs work as expected and really well. Basically connecting the data dots. And you're talking with Tilores and Kern AI today. So we are joint presenting, which is really exciting. And just to dive into a bit of who we are and what we do, we'll do that now. And I'll pass over to Stephen from Tilores. Please introduce yourself.
Thanks very much, Jason. Yeah, I'm Stephen. I'm the CEO and co-founder of Tilores. We are a data infrastructure company based in Berlin, Germany, and we help companies do fuzzy search and entity resolution of structured data, typically customer data or company data. And I'll explain that a little bit more throughout the talk, but really happy to be here presenting with you guys. So looking forward to the webinar.
Thanks, Stephen. And Leo. Yeah, over to you.
Yes, thank you very much. My name is Leonard Püttmann, and I'm a solution architect for machine learning and data science at Kern AI. And at the end of today's webinar, I'm going to dive into some technical details for which I'm very much looking forward to. And with that, I give it right back to you, Jason.
Thanks, Leo. Thanks, Stephen. Yep, and I'm Jason. So I am the go-to-market manager at Kern AI. And at Kern, we help organizations build really trustworthy Gen AI, LLM applications into their businesses. And I spend a lot of my time focusing on use cases that could be useful for organizations that can be built on top of Kern's developer AI platform, which has been a pretty exciting place to be in the last 12 months. And it seems to be going that way as well for the next 12, which is awesome. And just, there's a little bit of covering. I'm going to hide a few people and keep myself on screen. And so in terms of Q&A, this webinar is going to last around 30 to 40 minutes, and then we will be happy to answer all questions. But in the meantime, please write all your questions in the comments on the LinkedIn Live event, and we'll get to them at the very end. Happy to stay on until 2 p.m. our time, or even longer, to answer any questions. Or after that, any follow-up, feel free to please reach out to us. So yeah, type in all your comments and we will get to them at the very end in about half an hour or so. So let's dive into a few things. So what's the goal of today's webinar? There's two big goals. One thing I've mentioned already, we want to help everyone here understand a little bit about the components involved in building highly accurate Gen AI applications. Key focus on entity RAG today with LLMs. And also we want to help people maybe discover a few cool, interesting use cases that they can develop using our components that we're going to talk about. And in general, all content that we're creating is all about helping organizations eliminate barriers facing the adoption of Gen AI. Great potential in the technology. It's still quite new. A lot of organizations are definitely facing problems and challenges, and we want to, help them overcome them and really get the value they require out of their applications. So that's generally what we're always trying to do. So why is entity RAG important right now? Dive into a little bit more about what it is, but why are we talking about it today? And basically, one of the biggest challenges organizations are facing when implementing Gen AI is a minimal error tolerance. So errors or hallucinations in GenAI applications occur when an AI is providing wrong or misleading information, working as it's not expected to, which is pretty bad for AI adoption. And it can lead to a few challenges along the way. Hallucinations lead to a loss of trust in AI applications. If an AI application is giving you misleading information, chances are you're going to stop using it. Less usage, less adoption going forward. So we want to try and avoid that. Errors can lead to bad customer experiences. If a Gen AI application is maybe customer facing, you gave wrong information to them, it could lead to some more financial issues down the line potentially. Chances are, again, that's going to be a rule blocker for any further use cases. Or it could also lead to broken workflows or automation. And we want to avoid the AI being a weak link in any automation. It's meant to be the star of the show. And so any errors can cause a multitude of issues, and that's exactly what we're trying to avoid. And we think this approach can really help us do that. Just to give you a quick, a simple explanation of what RAG is, just for those that maybe don't know it in the audience. So Retrieval Augmented Generation, and this is a really simplistic view, but RAG is the process of adding more context to an LLM prompt for the accurate retrieval of company data. Now, the example here I've got, maybe it's not too clear, and I'll share the slides with you after if you could take another look. But in this example, we're just using the standard ChatGPT. We've asked them a question on the left, a very generic question, and we've got a very generic answer. We've asked about an insurance, a kind of external consultancy related to an invoice. Now, ChatGPT was able to answer the question, but it answered based on its generic learnings of what it's been trained upon, and it wasn't actually relevant to our business use case. So it gave an answer, not so good. On the right, we've asked the same question, but we've also input more information regarding a particular clause in an invoice. And in this example, ChatGPT was able to take the question, take the relevance from the extra input we gave it, and it gave us a much better quality answer based on its general knowledge, plus the added information of the contract that we added in there as well. And that's really what the RAG pipeline is all about. Adding more context, the information, giving large language models all the information they need to derive the best possible response that is expected for the customer. And so what are the building blocks? Diving into like another level down, we've got data quality. So if you're running an AI application that's meant to answer particular questions on a domain, it has to have the data feeding it, otherwise it's never going to answer the question. So the data and the quality of data is very important. Definitely one of the first building blocks. Intent understanding, which is based on the example I just showed you. We want to give LLMs a chance to understand what the user is really asking about. In our example, the user was asking about a particular contract in an invoice. So we gave it that extra intent so it understood that's what it should be referencing. Then the RAG process is meant to retrieve the information at a high accuracy, and that's basically an element we're diving into today with Entity RAG, is the ability to drive the right information at a high hit rate, basically make sure it's the right part. And lastly, the large language models. I would say large language models come towards the end of the processes and they're pre-components ready for large language model to then being able to use its magic to derive the answer we want. So that's kind of a few building blocks of RAG as well. And we'll dive into that in a lot more detail as the webinar goes on. But right now, I'm going to take a step back from RAG and just go over some of the use cases that we're developing with this components and this process, and also what we'll be talking about a little bit more when we give our demo later. So we're today focusing on a customer service application, a first level customer support assistant. So in this example, imagine you work for an insurer support team and you have a customer who's had a particular question, maybe about a claim or a policy. They'll maybe send an email or maybe a letter by post, and you're the support agent that has first access to that customer query. That's who this use case is covering for today. Why this use case? So we've implemented a couple of customers, they see real value from it, and there's a few benefits that they are experiencing. Number one, it helps support agents quickly find answers to some of the most complex customer queries, and often reducing research time by up to 90%. So historically, when a query comes in around maybe a more complex policy or claim process, the support agent might go to the documentation. It could be some PDFs in this example, and they might use some more manual process to try and find the right element of the policy they need to find the answer. And they might use Control F, search down, find the relevant fact or information, and then they might try and rewrite it for the purpose of the customer, which is quite a time-consuming process. With a support assistant, basically you have the AI driven by all the policy, product, claim data. And then there's a chatbot, a little bit like you see with ChatGPT. And the support agent can basically ask a question of this AI. AI then uses the right process, the components we're talking about today, extracts the right information, the relevant facts from the database, and then creates a summary for the support agent, which really streamlines the process. Plus, it can also help reduce the number of queries being escalated to maybe second level or third level. Basically, it's giving a lot more knowledge to the first level support agents to answer more questions, which is a great benefit of resources in support teams. And also it improves customer experience. If you can get the answers to the customer quicker, perfect. That always increases customer satisfaction. And that's what we're seeing with the leveraging Gen AI for customer support. It's just better customer interactions and a lot quicker responses, which becomes a real benefit for businesses and a real edge in acquiring customers. And so just to dive a little bit deeper of what this could look like, this is how a typical Gen AI application works. You've got your database, support, policy, product. It could be any kind of data regarding the business, the Gen AI application that's running large language models, a RAG process, chat UI. So a query could be, again, looking at an insurance example for this. I had to cancel my trip due to a family emergency, and they're asking if their coverage gives them any benefit here, if their global guard coverage would give them some money back for the loss of the trip that they can attend. AI accesses the policy documentation, generates a response, and then a response would be a little bit like this. I'll just hide myself quickly. Quite quickly, either copy and paste that or tweak it, but then send it over to the customer. And the use cases can become a lot more complex than this as well. And that's the real value of Gen AI. And just linking this back to RAG really quickly. So database, then it's a RAG process, that the pipeline, then that's feeding the final chat UI interaction for the support agent. So kind of the same steps, we'll be diving into that. And lastly, from me at the moment, just so we can talk about some cool other use cases that are using RAG and entity components, technical support. If you offer a highly specialized product that takes a lot of training and onboarding for new staff, you could get Gen AI to help speed up that process, hold all the knowledge, make that knowledge accessible, and also put it in the words where maybe the new joiner or maybe the customer would expect as well. So it really helps that initial stage. Historical query researcher. So if you've got a lot of past claims and you've got a new claim coming in that could have maybe been dealt with previously and you want to figure out how, you could load up the database of all the queries from the past. It could be by emails, documents, etc. And then basically have the ability to ask a question, a case that involved these details, has it previously shown up, and how was it then resolved? Maybe what customer related to, et cetera, the values of policies or payouts, which are pretty powerful. Training assistant, so any new members, if they want a more consistent experience when joining, or they're just not up to speed yet on any type of topics that are company-wide, training assistant Gen AI is great, and that really leverages RAG. We've got insurance policy assistant, so this is more of a domain-specific AI assistance. So you can really fine-tune Gen AI for domain expertise. Policy, again, we've seen a lot of requests for this. I think it's a big resource management process for insurers in terms of dealing and understanding different policies and products. Gen AI is great for helping with that as well. Medical assistants to provide medical professionals insight to a patient's previous treatments. Again, going back, understanding what happened and deriving the information basically instantly, rather than spending hours looking for the data manually. Or maybe you're just looking to implement your own custom GPT across different teams in your organization. I think that's a really powerful use case right now. Basically give everyone the ability to have an assistant that can leverage RAG to provide the right information at the right time to the teams across organizations. So that's some other ideas as well. And on our website, we have a use case catalog that has even more ideas, and we're happy to kind of talk about them at another time as well. And that's use case part over. Part two, we are into entity RAG and with Stephen. And so I will pass across to Stephen. Hello, I think you're gonna share your.
I am going to share my screen, and I guess we've lost Jason for a second, but thank you for the introduction to the webinar. So taking over and talking about entity RAG. So if you are thinking, hey, I've never heard the term entity RAG before, then you are not alone, because this is the first time we've really talked about it. What is entity RAG? It's a combination of entity resolution and fuzzy search as a data source for large language models to make them, as Jason explained, more trustworthy, more reliable. But to make this a little bit more clear, we have to take a little bit of a dive into what exactly is entity resolution. So one of the problems you have if you're working with, for example, customer data in any sort of large organization is actually accessing and finding the customer data. So you'll find that in most organizations, customer data is very siloed. It might be held in different databases. It might be held in different systems like CRM systems, customer support systems, marketing tools. And you will also probably have a large number of duplicates of your individual customers. And that's obviously bad for the LLM, because when it is trying to retrieve data about an individual, how do you know it is retrieving data about the correct individual? And how do you know if it is retrieving all the data about that individual? This is the problem that entity resolution solves for many use cases, and specifically here for large language models. So how does it do this? Well, and why is it difficult? Well, the problem with real world data is that there's usually not a primary or unique key that you can use to match the data together. You know, if everyone had one ID number and that ID number was always associated with their data, there wouldn't be a problem. But the reality is that that doesn't happen. So we've got an example here of our friend Vincent van Gogh, who is living in a particularly difficult to pronounce street in Glasgow, Scotland, called Sauchiehall Street. And you can imagine that this Vincent chap could have 3 different profiles in a system where his name has been potentially misspelt, his address has been misspelt, he's using a different email address, he's using a personal email address, using a work email address, he's maybe making variants of his personal email address, using like the plus sign afterwards. He might have different phone numbers. His phone number might be in the database in different formats, and it makes it pretty difficult to actually just link that all together and say this all belongs to one person. So entity resolution is about making these graph views of record data. The record data can be anything. It can be people, it can be companies, it can be products, it can be places. Anything that is an entity in the kind of a real world sense is something that you can link together using entity resolution. What we're particularly good at doing in this space is doing it with any volume of data, any number of data sources, and doing this data matching in real time. So broadly speaking, the way it works is we have a large number of fuzzy matching algorithms within Tilores. You build up rules based on combinations of these fuzzy matching algorithms, so it can detect that Vince Gogh is actually the same as Vincent van Gogh, because, for example, Gogh and Gogh are phonetically the same. Vincent and Vince are very close in terms of number of characters in them. And then you might combine that with geo-matching. So you would enter those addresses into an address normalization system. It would normalize the address, correct the address, put geographical coordinates onto them, and then you can see, okay, they have the same coordinates, or the coordinates are within 50, 100 meters of each other. Therefore, that's the same address. And depending on the use case, you might also use time as a factor for matching. So that's typically something that's done when you're using entity resolution for matching together transactions in the kind of money laundering and fraud prevention world. You'd say, okay, these transactions happened within an hour of each other. They have other attributes that match. Let's link them together. So in this case, what you end up with is this dynamic 360-degree view of your customer, which hopefully has all the data about that individual person linked together in one place. So again, we're very much kind of a data infrastructure company. And just recently, we've had a lot of people contacting us saying, hey, could we use Tilores as a data source for large language models? And of course, that makes perfect sense. We can connect into whatever source of data you've got about customers. We can become this kind of layer, a source of truth layer in your own data infrastructure, deduplicate and link all these entities together so that all these records together, so that even if they look different, you're able to access them all together with one query. And then I mentioned there's also the fuzzy search. So Obviously, once data is in Tilores, you have to be able to access the data. That works in a very similar way, fuzzy search. So you're searching for someone's name. There's a good chance that you do not manage to search for the name correctly because you spell it wrong, like with our friend Vincent van Gogh. And the entity resolution system will take into that into account and hopefully find your result, even though you've not got the name perfectly written. Therefore, that's how Tilores works with Kern AI as one of the data sources within the kind of the Kern RAG flow. Now, if you've come from any sort of data background, you'll be familiar with the sorts of typical data sources that are used in large language models, such as graph databases and vector databases. They, of course, all have their place in the kind of the modern data stack, and especially in building large language models. And vector databases are especially good at doing the kind of extracting data from unstructured data. That's not something that Tilores currently does. We're really much focused on this record data. So you have a record and you have attributes about that record. So we are able to define these distinct entities so that you know that all the data about one person is contained in that individual entity graph. As you might have seen from the structure of the data, one of the peculiarities of when you link this data together is it has what's called transitive hops. So you might search for record A and you find it, but record A is connected to record B, is connected to record C, is connected to record D. And the difficulty is finding the information about record D using the information which found record A. That would normally require many recursive searches if you were doing it in a graph database. It's basically not really a normal thing to do in a vector database, but it's what entity resolution is ideal for, and that's why it's very good for retrieving data for RAG. Also, if you're working in a kind of regulated environment, one of the advantages of entity resolution is that you can very easily define how these entity graphs have been built. So in Tilores, when you have this entity graph of all the records connected together, within the data itself, it shows you the rules which are used to make the connection from A to B and from B to C. And believe me, if you're ever speaking to a regulator about your entity resolution, which if you're in a regulated industry, you will do, they will literally ask you which algorithms you're using to match the attributes, what thresholds you're using for the matching. And Tilores is basically built to be able to handle that sort of interrogation and data privacy type questions out of the box. So, and Tilores Entity RAG is not replacing graph databases or vector databases, but for certain types of data, it's an ideal data source for your large language models. And with that, I will hand over to Leo.
Wonderful. Thank you very much, Stephen, for this fantastic introduction into the topic of entity RAG. I'm very quickly going to share my screen with you now. Perfect. And with all the knowledge we now have about RAG and the use cases for RAG, and also about entity RAG, let's jump into the third and final part of our webinar today, where we take a look at a demo showcase and build up all of this in practice, and also do a comparison with a baseline RAG project, a very simple RAG project, and an entity RAG project. So let's dive right into that. For that, we have prepared in total 3 different use cases, which all cover the health and travel insurance industry, so that we could ask questions about insurance policies that we perhaps have. For that, we have built up a very plain, simple RAG project containing just a vector database and a large language model. So a super basic setup, just to see how this setup will fend itself against the more enhanced RAG setup that we have in our second project, which contains more nuanced and more detailed nodes for data processing, and which also contains some of the magical components that we here at Kern AI have built, especially for these RAG projects. And taking everything to the next and final level, we then have the enhanced RAG plus Tilores, which is basically the entity RAG that Stephen just talked about, and which combines the best of everything to give you the most precise and accurate answers. And all of these projects were built in our platform, which is Kern AI Cognition, which provides you a lot of fantastic tools to get started with retrieval augmented generation very, very quickly, but which also gives you the freedom to customize everything to your needs very easily, so that you can build up the project that you need and that you want. And for that, we have a really big diversity of pre-built nodes that you can use in our platform. For example, here you can see that we have nodes for retrieval, so that you can build up your own sort of mini search engine on your company internal data. You have a big variety of different large language models that you can use to generate answers or to transform your data, to extract specific information from your data. But you can also include custom code into your projects if you need more customizability, or if you need some special connections for your projects. You can do that very easily with our platform as well. Now let's talk about the very simple and plain RAG setup, which just contains a retrieval node. Here we have a vector database, which you can really think of like a mini Google on your own company internal data. So you can ask a question about a specific product or tariff that you have, and you will get some results from the retrieval node here, which we can then feed into a large language model. In this case, we are always going to use OpenAI's GPT-4 to get the best possible answers. Now let's take a look at how the answer from such a very basic setup would look like. Imagine you're a user and you're currently on a holiday with perhaps your pet, and on the beach, sadly, your pet got into an accident or something like that. And now you reach out to your insurance to find out if all of that is perhaps covered by your policy. And the answer from this very plain and simple RAG approach is not very good. And the answer from the language model is basically saying, I don't really know. It's probably best if you look into the tariffs and the policy yourself, because I couldn't find anything useful. So kind of disappointing. Let's take the RAG to the next level with the enhanced RAG approach that we built in our second project. Here at the beginning of our pipeline, we add a transformation language model, which is a language model that takes in the user question and kind of reformulates everything, so that in the second step, in the search for relevant information in the retrieval part, we are much better able to find the right results and the right pieces of information that we actually need to give a correct answer with the language model. In the third part here, we have a custom-made re-ranking model that we at Kern AI built, which is able to sort out irrelevant and unneeded search results from our retrieval component. Think about when you do a Google search, for example, not all of the search results are going to help you answer a question. And ideally, you want to remove all the irrelevant and unneeded search results from a query. And that's exactly what our re-ranking model is doing, ensuring that only the relevant parts end up in the fourth and final part of our pipeline, the language model, which can then give a much better answer to you, the user. And we are really proud of our re-ranking model. Here's another visualization of how this works. Basically, you have a vector database containing all of your data, and the vector database is only really good at providing you similar documents in regards to a question or a query from a user, for example. And the re-ranking model that we have built and deployed here is then able to filter out everything that we don't need to provide a good answer, and just give you the top relevant data points and documents. So let's take a look at the answer and the response from our language model in this enhanced RAG pipeline. And immediately we can see that the answer is much more nuanced and to the point. It is much more helpful, because now we get an actual response to our question if the incidents that we had is covered by our policy. The model is saying, in your case, it doesn't look like the incident is actually covered, but The model is not mentioning any specific tariffs or policies that we have. So the answer is definitely more helpful, but some of the ambiguity that we might have still remains. So let's tackle that in the next part, in which we include Tilores to get more information about the user and give the best possible answer in this case. For that, we add some more transformation language models at the beginning of our pipeline to extract the surname or the first name of a user, for example. But you could also, of course, use these language models to extract all kinds of information that you are interested in. Then we pass all this information to Tilores, which can then give us some more detailed information about our user, even if the information that the user stated is perhaps a little bit fuzzy or vague. And then in the second half of our final project, we still have our enhanced RAG pipeline, which contains all the really, really cool components like the custom re-ranker I showed you previously. In our case here, we are going to use the API service of Tilores, but of course, they also offer a very cool user interface in which you can check out all your entities that you have in your database, in all the information about the entities, like the names, plans that are active, and all those cool things. You can inspect that in the user interface right here. Or you could also, for example, modify the schema that you use for your API. So very cool stuff here as well. And then we take the user question, get the relevant information from that question that we need to do the entity search, and we pass that to Tilores. And maybe you've already spotted this before, but the name of the user here was actually misspelled. The first name here should be Mitch, but it wasn't spelled correctly. But that's not a problem at all for Tilores here, because what we retrieve from the service, from the API in this case here, is actually the real entities with the correct spelling of the name, and also with all the active plans and active policies, with all the dates, and for example, also a postal code, so that we could validate the user if we would need to do that, for example. Checking out the final answer, the enriched answer, we can see that it's much, much more helpful than the original answer from the plain RAG approach. Because here in the final answer, we get a clear and concise answer that is specific to the policies that the user has, and it's very clear and helpful right away. Whereas the original answer didn't help us at all and wasn't really useful in any way, really. So this should really highlight why Entity RAG is such a powerful approach, and why it can help you very, very easily to get much more accurate and much more helpful answers from these RAG projects. Cool. That's it for the third and final part of this webinar. Thank you so much for joining in today and for watching, and we sincerely hope that you learned something useful today. And with that, I give it right back to Jason.
Thanks, Leo, and thanks, Stephen. Yeah, that is the end of our section. Hope you enjoyed it and found it useful.